Hello, this is Adarsh Pradhan from Department of Civil Engineering, Tech University, and my project partner Israel Gurung. The project that we would be presenting is on strengthening and premix carpeting of Chongrang-Kongri S.P.W.D road at Gyalshing, West Sikkim. The proposed location for the above project is West District of Sikkim and the block Gyalshing. Why do we exactly need to carry out this project is since the area of Gyalshing is a hilly region, so there is lack of metal roads which can be utilized for a smooth transportation. So in order to overcome that, the S.P.W.D of Sikkim is undertaking this project. In order to start any project, the initial surveying needs to be done. There are two basic types of surveying, which includes chain surveying and cartridge surveying. In chain surveying, it is one of the simplest processes of measuring the distance with a chain or a tape, wherein the chain number is marked and the further readings are taken. These are the pictures of our supervisors carrying out the surveying with instrument for setting out a grade contour. Furthermore, pictures which shows the hilly terrain wherein the road has to be made, as well as the work carried out. These are certain technical aspects of the road, ranging from the alignment, its gradient, and what is the pavement width which is expected, the drainage which needs to be provided in order to maintain the bituminous layer on top of the road. The road structure is expected to be flexible because of the uncertain environment in Sikkim, and which needs to be taken care in cases of heavy rainfall and certain traffic. Various laboratory tests that those are performed on the material are enlisted, such as the fineness modulus of a sand, wherein the sieve size with the cumulative percentage retained and the percentage that passed were noted down, and they were further optimized to use in the manufacturing process. Following, the aggregate impact test was performed, and these are the certain results those were obtained through the sieve analysis, and the sand content and the silt and the clay content was determined based on the test results. This is the graph showing the sample passing percentage and the sieve size in There has to be, since the terrain is hilly, the protective work needed to be done around the road in order to maintain the in order to sustain the strength of the road. These are the protective works which are performed to provide the support and strengthen the road through stones and the bond stones provided as CRSM to improve the bonding between the stones. Now the further presentation will be continued by my project partner. Thank you.
I would like to continue with the presentation. The types of walls are retaining walls and the breast wall. The retaining walls are along the valley side and the breast wall is along the road side to protect the loose soils above the road. So, uh, the walls are constructed as plumb wall and CRSM wall. Plumb wall is the mix of 1:2:4 cement concrete, and the aggregates are used 20 mm and 40 mm size, and shutterings are done in order to get a smooth finish by steel and plywood. And the other one is CRSM, which is known as coarse rubble stone masonry, and it is a mix of 1:3:6 cc, and chiseled red stones are used for this. And there's another type of gabion wall, and this is mainly used in the hilly region and in the area where there is full of water. Stones are used of the larger size, that is above 100 mm, and are built in compartments. Now the design is as per flexible pavement. The flexible pavement is as base course and surface course. And flexible pavement is dependent on traffic count data, and this particular data has been taken out from the traffic control department. And these are the calculation of average annual daily traffic, which is important for the flexible pavement. Now these are the details of the pavement layer. The sub-base course is 100 mm thick, and waterbound macadam 2 is 100 mm thick, and 3 is 75 mm thick, and bituminous layer is 20 mm thick with a seal coat of 6 mm. So before constructing the road surface has to be prepared, and as it is a hilly region, the edging has to be done properly. Now the sub-base 1. Here the aggregates of 40 mm size is used, and it is 100 mm thickness, and sub-base 2 is used 40 mm stone aggregate, and the thickness is 75 mm, and this has to be rolled with 8 by 10 ton roller. Now after this is a layer of bituminous surface. This has to be 20 mm, and aggregate used is 20 mm in down size, and this has been rolled by 80 by 100 mm. And there is a laying of tackot which comes between the bituminous layer and the sub-base and the base course. So this is done by mixing of sand and bituminous. So this is the laying of bituminous concrete with paver, and it has been rolled by 8 by 10 ton roller, and these are the photographs. And the last layer, which is seal coating, is done, and it is 6 mm. This is also a mixture of fine sand and bitumen. This is used to seal the previous coat and the bitumen layer. Conclusion: for the construction of G-pavable road, the width of the road is 3.75 meters, and camber slope has to be maintained as it is a hilly region, and proper drainage facilities would be provided in order to protect the bituminous work. Thank you.